This is 4.3. We're talking about logarithm functions. And again, some of this stuff you should have touched prior in another class, so let me go over it. A logarithm is nothing but an exponent. That's literally all it is. It's just written in a different way. So this literally is referring to exponential. This whole chapter is referring to exponential functions. And so this is another way to write it or consider it. So log base A, so that's how this is pronounced, log base A of x equals y. Now what that literally means is a to the y power equals x. Now the way I remember this is I go counterclockwise. So I go a to the y power equals x. Now that's how I remember it. So whatever system you want to do to help remember it, but that's how I would do that. So if I gave you log base 2 of 8 equals 3, notice 2 to the third power equals 8. See, that's what I have written here. And by the way, I have double arrows, meaning, if you remember back in geometry, you started learning these, and that means it goes both ways. So, 2 to the third power equals 8. Literally can be written as log base 2 of 8 equals 3. So you need to know how to write it both ways. So log base 5 of 125, so that literally means 5 cubed is 125. Log base 4 of 16 is 2, well, because 4 squared is 16. So what if I had 3 to the 4th equals 81? So this is an exponent right here. 3 to the 4th equals 81. Well, that could be written as log base 3 of 81, because 3 to the 4th equals 81. So make sure you're familiar with how to write that, going from logarithm to exponent and then exponent to logarithm. So if I ask you to evaluate each of these without a calculator, so log of base 4, matter of fact, some of your calculators will not, some of your scientific calculators won't even do base 4 or base 2. It doesn't allow you to change the base, but you need to know how to do this without a calculator. So literally what this is referring to, remember if you go counterclockwise, 4 to some power, so we're trying to find out what that equals. So 4 to some power equals 64. Well, that's 3. So this equals 3. And the same thing here, we're trying to find what power here. So 2 to the what power equals 32, and that's 5. So that's the fifth power. Same thing here, 5 to what power is 625, and that would be to the 4th power, so this equals 4. So now let's go backwards. How do I write 4 to the 5th? If I know 4 to the 5th equals 1024, how do I write that as a logarithm? Well, that would be log base 4 of 1024 equals 5. Remember, 4 to the 5th equals 1024. Same thing here. Log base 6 of 216 equals 3. Again, because 6 cubed equals 216. So let's talk about properties of logarithms. So if you have logarithm base A of 1, the answer is 0. And remember, here's the reason why, because a to the 0 power is 1. Anything to the 0 power is 1. So here's an example, log base 5 of 1. If I ask you to evaluate this, you would write 0, because 5 to the 0 power is 1. So another logarithm property is if you have log base A of x, log base A of a to the x power, the answer is just x. So anytime these bases and the base of logarithm and the main base here, if they ever repeat themselves or they're the same, then the answer is the exponent. So here's log 7 of 7 cubed. Well, again, the answer is just 3. Well, another property is if you have a raised to the log of base A of x, again, if these ever match, the answer is just x. And here's an example of that property as well. So let's talk about common logarithms. Now, common logarithms are logarithms with base 10. So if I just write log of x, you have to assume that that's base 10. If I don't write a base, then you have to assume it's base 10. So that's really what that means. That's called a common logarithm. So if I say, what is the log of 100? Well, you know that the answer is 2, because 10 squared is 100. So again, you have to assume, that's a common logarithm. If I don't write the base, it's base 10. Now let's talk about the natural log, or ln. Well, if you ever have log base e, and we talked about e in the last section, so log base e of x is literally referred to as the natural log. So again, another way, if you look at some of these properties, so e to the ln x, e to the ln x equals x. So these literally are inverses of each other. They're inverse functions. Matter of fact, if you look at the calculator, the ln button and the e to the x power are inverses of each other. You can see them; they're on the same button here. So the properties are very similar to the last one. So here, if we have ln of 1, the answer is 0 because this literally means log of base e. That's really what ln stands for of 1. And so the only way it's going to equal 1 if this is 0. So e to the 0 power is 1. So that's how you evaluate. And again, we already talked about these are inverses of each other. So the ln of e is 1. Ln of e raised to the x power is x. Again, they're inverses of each other. And the same thing here, you can see they're inverses of each other. So we can x. So if I ask you to evaluate here's some examples here. So if I had ln of e to the 8th power, remember ln and e are inverses of each other, so the answer is 8. And think of this as ln, and e to the negative second is the same as e to the 2nd power, because the negative exponent is, you're going to flip it. And these are inverses of each other, so the answer is 2. And here, ln 5, this is just a matter of using your calculator, just evaluating the natural log of 5 and getting your answer of 1.6. And then depending on how many decimal places I tell you, so let's say 1.61. So let's talk about graphing. So graphing is, if I graph two functions that are common, the log function and the ln functions. So notice both of them look very similar to each other. Remember, this is nothing but the log of base e. Okay, so they're very similar to one another, just different bases. Remember, this is the common log, so base 10. And so you can actually evaluate this, but I do want you to notice the reason why there's no, like on the XY chart, there's no 0 here. So because you can't have something that it's not going to be defined at 0. So if you look at your calculator, it's actually an error that comes up when you try to plug in zeros to the logarithm. So this graph gets closer and closer and closer, but there's an actual asymptote here, so it doesn't actually hit 0 here. So it gets very, very close here, and then it slowly keeps gradually climbing up higher and higher and higher. The same thing here. Again, this is a logarithm, just a base e. So there's an asymptote right here, so it does not approach that. So you need to be familiar with, this is the parent function. You need to be familiar with that. And likewise, if I had log base 2 of x, so how do you do this if your calculator can't change the base? Well, how do you do that? Well, think of this as this is 2 to the what power equals x. That's what we're trying to find. Well, start thinking of all your 2 to the, whatever power it is. So what if I had 2 to the 0 power? Well, I know that's 1, right? So 2 to the 0 power is 1. So, and I'm trying to find x's. So this is 1, and the answer would be 0. So you could literally calculate this over and over and over. 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16. And then you can start talking about the negatives as well. So this would be 1/2. This is 2 to the negative second is 1/4. And you can go on and on and on. But you can start evaluating these yourself to be able to do that. So for instance, 2 to the first is 2nd power. So that means the log of base 2 of 2 is 1. That's really what that's referring to. The log of base 2 of 4 is 2. So notice what you can do. You can literally create your XY chart, and then you can create your own XY chart and then plot those points and graph it. Again, it's the log function, the parent function. It's just because of the base, it has a little slightly different numbers, and you just have to calculate all those. And then one last thing, is shifting. We've already talked about this with referring to other functions. So if I have these g of x function, so notice the parent function log of x. The parent function is log of x. But notice I'm adding 2 to it on the outside, and all that does is it shifts it up 2 spaces. So take the parent function, make sure you're familiar with that parent function, and then shift it up 2 spaces. And remember a number on the inside of this, whatever the function is. So in this case, it's shifting it 4 to the left. So take the parent function and then shift every point 4 spaces to the left. And that's logarithm function.